This is Pre-Calculus Concept 10C. We're going to be talking about graphing inverses, and there are three boxes. Box 1 here is an important concept. What I want to remember about f and f inverse and their graphs is that they are going to be reflections of each other through the line y equals x. So I've got a picture here to help us see this, but if I consider two functions, I'm going to make the function on the right here f, and the function on the left here f inverse. And notice I also have the line y equals x shown because that's an important line of reflection. Those two graphs, hopefully you can see, are reflections of each other through that diagonal line y equals x. If you tilt your head diagonally, you can see that symmetry. And another important thing to watch out for, and it will always be true if you have inverse functions, is that every point on one function is going to have a corresponding point on the other. And hopefully you can notice that relationship. The x and y coordinates are flip-flopped. So just like in our inverse process, when I flip the x and y, you're going to see that on a graph and its inverse. If I look at a second point on the graph of f, 3, -2, then the f inverse has to have the -2, 3 point. And I've got a third point here that's also reflected, but if you take -5, and you reflect it through the line y equals x, you're going to swap the coordinates and you also have -5, -5. So that's actually a point that's on both graphs. Alright, so again, in summary, a function and its inverse will always be reflections of each other through the diagonal line y equals x. Alright, box 2 is an example. We're going to start with a function and call it f and try to come up with its inverse, which we'll do in red. The inverse will be f inverse x. Alright, I'm going to do a couple things to help us out here. I'm going to draw in a diagonal to represent the line y equals x. Remember, that's going to be my mirror. And then I'm going to think about each of these points reflected. So 2 is going to become 2, 6. And 4, -2 is going to become -2, 4. And 0, -4 is going to become -4, 0. I want to sketch my graph of f inverse. I'm thinking about every single point on the graph of f being reflected through this line, and I'll do my best to think about what that would look like. Since my original graph is 2 line segments, then my reflected graph should also be 2 line segments. I should see that symmetry through the line y equals x, and you can label these points just to help emphasize that the points from the original function have corresponding points on your inverse function. So that's going to be -2, 4, and our third point was -4, 0. Okay, so I have my original function f and the f inverse graph shown. Alright, box 3 is a u-try. I've got a picture of a function shown below and 3 points on that function. This function has a linear section and a kind of square root section. Your job is to sketch f inverse. Take a minute and draw a sketch of what you think the inverse would look like. Alright, so I've got a picture here of f inverse in green. A little hard to be perfect about this, but you do want to see the symmetry between the graph of f, shown in black here, and f inverse shown in green, and especially the reflected points. So hopefully you had 2, 6, 0, 2, and -4 or -6 on your graph. These graphs do cross each other, and they cross each other on that red reflected line y equals x.